But another way to look at an image is by splitting those channels. So if I take those images and instead of looking at the color value, the three numbers that make up each pixel color, if I instead treat all the red values as if it was one image, all the green values as if it was one image, and all the blue values as if it was one image, those are what we call color channels. And what I can do is I can actually use Pillow to split my image into color channels. And that's useful because now I can see the red, the green, and the blue in the picture. Obviously, a picture of a strawberry is mostly red and green, but not a lot of blue going on. That's why it's so dark. And in fact, the most blue you see is in the areas of the light reflecting off of the strawberry where it's actually more of like a white color. So that's where the blue's coming in. Red, obviously, fairly intense around the strawberry. The green shows up more in the leaves. Okay, so the lighter the pixels are in this, the closer that value is to 255. A perfectly white pixel, something like this maybe, would be almost to 255. And if the pixels are dark, that would mean an absence of that color. But the nice thing about this is that I can now enhance the image. If I want the image to appear more green, then I can take the green pixels or the green channel and I just brighten that channel up and it bends the whole picture toward green. I could increase the contrast and it would do something different. I could blur that channel, I could rotate it, I can do all kinds of things with just one of those channels. And then when I put the image back together, then it looks different. So splitting an image into channels is actually quite easy, and it uses this is the easiest way to do it. It's not the only way to do it. But if I use image.split, what it creates is a tuple that contains the data. I can use a shortcut of assignment, and we haven't even really done this much in class, but this is good practice for this. Anytime you have something that's split into a predictable number of parts, whether it's a tuple or a list, you can assign those directly to variables. So I know this is going to go into three parts, red, green, and blue. So I'm just going to assign them in one line of code, image red, image green, image blue. Now I've got three black and white images, one representing each of these channels. Let me show you in code because I think it's easier to see it. So I have my skate image, right? So it's this one. Let's just say image skate dot show. Let's take a look at that. Okay, so that's just that one right there. Normal image. So now I can take that image and I can split it here into an image for the red channel, an image for the blue channel, and an image from the green channel. And those are now three separate image objects, each representing the black and white version of that channel. So if I say image green dot show, then it's going to show me the green channel of that image. Very bright. Why is the green channel so bright? Well, this ramp isn't green, but what color is it? It's gray. So what do you expect if it's gray? What do you expect the other two channels are going to look like? Very bright here, right? Almost the same brightness because that's how you get gray. You can see here also the grass for green is up here. Let's take the green and the red and compare them. Image red dot show. Let's take a look at those next to each other just for comparison's sake. Okay, so we've got the red here and the green here. The green is going to be brighter in the grass. Now, this is Bakersfield, so the grass isn't super green, right? It's just sort of a greenish brown color maybe. Um, but you can see here it looks a little different. Let's try it with a different photo and see if we can get a different comparison. Let's see what else we got in there. Nacho. Let's try the Nacho Libre one. Any Nacho Libre fans here? It's a classic. Let's get the original open too. That way we can see them all together. Okay, so we've got a picture that is fairly warm colored, right? Oranges, reds. So we're going to have a lot of red. We are going to have a little bit of green because that's how we get those yellow colors. Blue. Let's see what blue looks like. Just so we can compare the three. Okay, so, you know what, let me close all these so I know what I'm doing. I had too many windows open at once. There we go. Okay. So we've got, there's the original, there's the red, there's the blue, I think, and this one's probably the green. No, this is the green here because that's why this is so bright because it's got that greenish tint to it. Unfortunately, these temporary names don't give me a lot of clue as to uh, which is which. Wasn't really made for this. So I can do that, but now I can do things like I can take any of these image objects and I can do anything I want to it. Like I can take one of those and rotate it. Did I do that image? Oh, I did it in the wrong order, so that's not going to be very helpful, is it? Let's put that in the right order. There we go. Okay, so now you can see which one is green for sure because it's rotated. But now if I put those back together, those pixels aren't going to align properly. So once we split it into channels, we get the grayscale image.